Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on nodal analysis for networks with dependent sources. For the following network, using nodal analysis, find Vx. So in the given network, as one end of the 2 kilo ohms resistance is open, there is no relevance for that resistance in the circuit. So it can be removed from the circuit. So redrawing the circuit after removing 2.2 kilo ohms resistance, that circuit becomes like this. Mark the node as node P, node Q, S and R. Mark currents associated with various nodes as I1, I2, I3, I4 and I5. Here, voltage at node P is given as -9 volt with respect to reference node. So, no need to apply KCL at node P. Let us apply KCL at node Q. Various currents associated with node Q are I1, I2, I3 and I4. So here I1 and I2 are the two incoming currents, while I3 and I4 are outgoing currents. Current I1 is given as Vp minus Vq divided by 470. I2 is equal to 7 milliampere, I3 is equal to 5 milliampere and I4 is equal to Vq minus Vs the whole divided by 10,000. So applying KCL at node Q, we will get I1 plus I2 is equal to I3 plus I4. So Vp minus Vq the whole divided by 470 plus 7 milliampere is equal to Vq minus Vs the whole divided by 10,000 plus 5 milliampere. So rearranging the terms, we will get Vp minus Vq the whole divided by 470 minus inside bracket Vq minus Vs the whole divided by 10,000 is equal to 5 into 10 raised to minus 3 minus 7 into 10 raised to minus 3. Vp minus Vq the whole divided by 470 minus Vq minus Vs the whole divided by 10,000 is equal to 5 milliampere minus 7 milliampere. Opening the brackets, we will get Vp minus Vq the whole divided by 470 minus Vq by 10,000 plus Vs by 10,000 is equal to minus 2 milliampere. So taking LCM as 47 lakhs, we can write 10,000 Vp minus 10,000 Vq minus 470 Vq plus 470 Vs the whole divided by 47 lakhs is equal to minus 2 milliampere. So 10,000 Vp minus 10,470 Vq plus 470 Vs is equal to minus 9,400. So here Vp is given as minus 9 volt. Therefore we can write minus 90,000 minus 10,470 Vq plus 470 Vs is equal to minus 9,400. Rearranging the terms, we will get minus 10,470 Vq plus 470 Vs is equal to 80,600. Equation number 1. Apply KCL at node S. There are three currents associated with node S, I3, I4 and I5. Here I3 and I4 are incoming currents while I5 is outgoing current. So according to KCL, we can write I5 is equal to I3 plus I4. I5 is equal to 0.2 V1, where V1 is equal to VQ minus Vs. Therefore, we can write I5 is equal to 0.2 into VQ minus Vs. I3 is equal to 5 milliampere and I4 is equal to VQ minus Vs the whole divided by 10,000. According to KCL, I5 is equal to I3 plus I4. VQ minus Vs the whole divided by 10,000 plus 5 milliampere is equal to 0.2 V1. But V1 is equal to VQ minus Vs. Therefore, VQ minus Vs the whole divided by 10,000 plus 5 milliampere is equal to 0.2 into VQ minus Vs. VQ minus Vs the whole divided by 10,000 plus 5 milliampere is equal to 0.2 into VQ minus Vs. Rearranging the terms, we will get VQ minus Vs the whole divided by 10,000 minus inside bracket 2VQ minus 2Vs by 10 is equal to minus 5 milliampere. 10,000 is the LCM. So VQ minus Vs minus 2000 VQ plus 2000 Vs the whole divided by 10,000 is equal to minus 5 milliampere. So rearranging the terms, we will get minus 1999 VQ plus 1999 Vs is equal to minus 50. Equation number 2. So we have two equations. Minus 10,470 VQ plus 470 Vs is equal to 80,600. Equation number 1. Minus 1999 VQ plus 1999 Vs is equal to minus 50. Equation number 2. Therefore, we can write VQ is equal to determinant of minus 10,470, 80,600, minus 1999, minus 50, divided by determinant of minus 10,470, 470, minus 1999, 1999. So we will get VQ is equal to minus 8.0861 volt. Thanks for watching Circuits Analytica. Enjoy learning.